All right, everybody. So my name is Danny Straub, and I built I modeled a desktop vortex waterfall in CAD. So I'm going to go through and talk a little bit about that. So uh, first, a little bit about my aesthetic. So I was targeting Apple's minimalist and modernist aesthetic. Um, they use a lot of brushed aluminum and really clean lines, and they really put a lot of emphasis on simplicity. So I try to incorporate those kind of principles as much as possible throughout this. And then I was using this image here in the center of the screen as kind of a design guidelines. So as I was going through my brainstorming phase and my design phase, I was kind of using this photo and asking myself, would my device fit in with the rest of these devices, the rest of the aesthetics of this image? So initially, I was going to make this water clock. So the idea here is that there's a pump down here in this compartment. This would be filled with water. The pump would send water up through this spout or nozzle. The water would then drip on a sensor, and from that readout, it would tick a clock and display the time on this LCD screen. So I was going to make all this out of acrylic. I was going to laser cut it and solvent weld it together. And once COVID-19 hit and the closures of the campus closures came into effect, it was just not realistic to get that manufacturing finished. So I decided to pivot my idea, take the time that I was going to manufacture this device and use that time to further brainstorm and further, target target my aesthetic. So I went back to the brainstorming phase and I knew I knew what aesthetic I was going for, and I knew I wanted to incorporate water, and I knew I wanted something kind of desktop size. So I was kind of looking through the internet, and I randomly stumbled upon these vortex waterfalls. And for those of you who haven't seen them, I want to pull up this video real fast and just kind of give an idea of what this looks like.
Gauge can be used to measure the shape of irregular items to create an.
And of course, there's an ad. So the idea here is that you have kind of a reservoir in the bottom of the device. The pump will pump water up into the cylinder and send it kind of in a spiraling fashion. And as the water fills up, it will create that vortex. And once the water level reaches the top of the cylinder, it will start to spill over the top and return back to that reservoir. So I saw that, and I immediately knew that was kind of the route I wanted to go. So I decided to make my own version of this. So here's my timeline. I allocated about 30 hours to go back to the brainstorming phase. I wanted to get that done pretty early, just so I had enough time to work in CAD and work on my renderings and animations. So from there, I took about 5 hours to model my device, another 30 hours to do the renderings, and another 30 hours for the animation, leaving about 20 hours for documentation. So here's my ideal design process on top, this figure on top. So ideally, I would define the problem, spend quite a bit of time brainstorming, prototyping and prototyping, and then iterating quite a bit on that. Then going through kind of a final build process, testing, and then further iterating. For this project, however, with the constraints of time and with time, my design process kind of looked like this. I define my aesthetic, then define the concept of the water vortex, brainstormed a little bit further, modeled, rendered, and animation, and then this section, this rendering and model section, was pretty iterative, just nailing down dimensions and getting the renderings the way I want them to look, and that sort of just. So here's the design. So on the right, you can see one of my final renderings that I came up with. And I'll get into the design a little bit, but just as an overview, I really used Apple's HomePod as kind of the dimensions and form factor of my device. So again, down in here, and I'll go further into detail here, but down in here, there's a pan that will hold water and the pump. The water will be routed through some vinyl tubing and up into the bottom of the cylinder. That water will be sent in that spiraling fashion to create that vortex. And as the water drips over the sides of the cylinder, it will return to the pan and continue to pump into the cylinder. So here's a design overview. So I removed the aluminum base here. So as you can see, I have the pump sitting inside this pan. It has this little receded section for the pump to sit in. Then I have the cylinder. That tubing is routed up through the bottom of the cylinder. And then I added a LED strip to add another kind of aspect to my design. So a little bit about the components. So first, this base is made out of aluminum, and I made it to be casted with some post processing and a brushed finish. So I incorporated uniform wall thickness to help with the cooling process in the casting manufacturing process, as well as some draft angles. And I wanted to exaggerate those draft angles and kind of give this a tapered look, just to give it a little bit more. I didn't want it to be a straight cylinder. I wanted to add a little bit more to that. So the pan would be made out of ABS, and I designed it to be injection molded. I wanted to gain a little bit more experience with injection molded design. However, I know that's for mass production, a way bigger production rate than what I was planning on. So this could also be machined, although it's not fully optimized for machining. There's a lot of material that needs to be removed. So I would iterate a little bit on the design of this if I were to machine it. And then I also wanted it to be transparent if possible. Transparency with ABS is a little difficult to get with injection molding. However, there is somewhat transparent ABS out there. But the reason I wanted it to be transparent is I wanted the LEDs that will be sitting in the bottom of the aluminum base to refract through, shine through, and get to the water. Again, this also has a uniform wall thickness and draft angles to facilitate that injection molding process. So my cylinder is going to be made of acrylic, transparent acrylic, and it could also be casted. It does have these organic shapes on the bottom, so that might require some design iteration when it comes to the manufacturing process. But nonetheless, I wanted to incorporate as many curves as possible. My initial idea with the water clock was pretty boxy, and I really just wanted to get as far away from that as possible. I toyed around with using polycarbonate or glass, but I ended up going with acrylic just to keep the cost down of the entire device. So here are some of the preliminary renderings that I made. As you can see, what I did here was I did a helical sketch down here, and then put a draft on that, a tapered angle on that, and then swept around with a circular cross section. And I started doing these renderings, and I was playing around with the different lighting and colors and backgrounds, and I just really didn't like the way this came out. It didn't really look like a vortex to me. So I decided to go back and change the way the vortex is modeled. So here, as you can see, what I basically did was, instead of making the water that fits inside the cylinder, I decided to make that from a sweep, and that way the height of that solid body could be changed. I did that primarily for the animation. However, long story short, I changed the vortex to be a custom extruded cut that was a function of the height of the water. So essentially, as the water rises, the shape of the vortex changes a little bit, and I'll show that here in a second in my in the animation I made. Because in real life, that vortex will start off as more of a bowl shape, and as the height of the water increases, it'll get a little bit skinnier, and then of course start to spill over the top. So as you can see here, it was really difficult to model that water spilling over the top, but this was the best I could get it looking. So on the left here, there's no LEDs on this version. And then on the right, you can see I added a red LED. So that light really refracts through and creates a pretty interesting glow. So here's a final animation I made. Unfortunately, I wasn't able to make it with rendered images. I wanted a high frame rate to make it look realistic. And of course, when you go to render an animation, it renders by frame. So this is done with 60 frames per second, and it's about 10 seconds long. And that rendering probably would have taken about a week to do. So I decided to just keep it in the raw model. And here's what that looks like. So the water would fill up and then start to spill over. You can change the color of the LED. So you saw it change to a green color. And then I added a little exploded view at the end there. So it's kind of hard to see how the vortex is changing shape. It's moving a little too fast to see that, but that's kind of where I ended up with my animation. So the next steps here would be to prototype this device. That video I showed earlier is a DIY video, so I could easily prototype this, determine what kind of pump I need, if the diameters of the cylinder would work, and so on and so forth. From there, I would determine the manufacturing processes I would be using for each part, and then iterate on the design if need be. Then I would procure materials and go back and play around with the renderings and animation a little bit more. So I would like to polish those out a little bit more. The renderings and animation is an extremely iterative and time-consuming process. So when I got it to the point I showed you, I was happy with it and decided to just leave it there. But I think I could go back and polish those up a little bit. Again, like I said, modeling the overflow of the water was really difficult to do with solid bodies. So I think there's probably might be a better way to do that. And then with the animation, I'd like to spend more time and render the animation frame by frame if possible. So in conclusion, the COVID-19, really it put a damper on my project, to be frank. And I was really looking forward to manufacturing something. But when I went back to the brainstorming phase, I was grateful for the extra time because I really did want to play around a little bit more with SolidWorks, hone some of my skill sets in there, especially related to CAD renderings and animations. So in the end, the whole project was really successful to me. I got to spend tens of hours in SolidWorks, so that was that all ended up being a win in my book. I was also able to achieve that stretch goal of creating that animation. Again, this was an extremely time-consuming process, so I'm glad that I got it to the point where I got it. So I'm ultimately happy with that. And then as far as aesthetics go, I really do feel like that product could fit in that image that I showed earlier on the second slide, and I think it targets the Apple aesthetic pretty well. So with that, I'm gonna put these questions up here and open them up for you. So what are your thoughts on the aesthetic? Does it match my target aesthetic? Would you buy one of these? And how do you think it could be improved? Thank you all.
Great, thanks, Danny. I was particularly impressed with your modeling of the water. That looked really impressive. I can imagine that probably took forever, but it ended up looking great. Does anyone have any other statements of meaning?
Thank you, Jackson. I appreciate that, by the way.
Yeah, I was really impressed with how your model turned out. I particularly liked the animation. I thought that was a really great way to show your whole product and kind of how it works and the exploded view and everything.
Thank you.
I really like what you ended up doing. And in fact, I own such a device that does this. There's a few out on the market, and they all have ugly bases. And I like the design of your base quite a bit. The part that encloses the pump and the pan and all that. So yeah, I would definitely buy one. If
Thank you. May I ask, do you use yours?
It's sitting up on a shelf here. It's you know, it's a water thing. I would have to maintain it if it were on my desk.
Right.
Keep the water clean, and I have not actually used it very much. I keep it as kind of a FlowViz thing, just because I collect them.
Gotcha.
But I don't use it on a daily basis. I have some other things. The pump noise is one issue. It needs to be very quiet.
Right.
I wonder if there'd be some way to make the pump motor remote so that it could be, you know, enclosed in something that would muffle the sound even more. Because all you want is to hear just the water.
Exactly. Okay. I will take that into consideration. Thank you.
I agree that I think you match the Apple aesthetic quite well. I think it really fits into their product line, especially with that curvature you were able to achieve. And I think the drafts kind of add to that aesthetic as well. Does anyone else have any other answers to the above questions? Then we'll move on to neutral questions from the audience.
One of the questions that I have is, it's hard for me to visualize how big this would be. I mean, I know they would fit on a desk, but like, how large are you picturing this?
You know, I I apologize. I completely missed talking about that. So it's about 8.5 inches in height, and about the cylinder is about 5.5 inches in diameter, if that kind of gives you an idea. So
Definitely.
yeah, so kind of like Nalgene bottle, a little bit more diameter than a little bit bigger diameter than a Nalgene bottle, but very similar dimensions to that, if that gives a reference.
Yeah, thank you.
Did you look at any fluid dynamics papers on bathtub vortexes? Because that's essentially what you got in the middle there, is what's called the bathtub vortex.
Yes, I did. And as I started looking into that, I don't have a lot of experience with incorporating equation-based.
That would be harder. Yeah.
Equation-based modeling in SolidWorks. So I did try to incorporate as much of the geometries that I could pull from those papers as possible. But no doubt it's a fairly complex fluid mechanics problem, and but nonetheless it's extremely fascinating. So that will be something that I will try to incorporate more in kind of my next revisions, if I decide to continue developing this maybe over the summer as a personal project, and kind of learn how to incorporate those equations into the SolidWorks model.
For a simple equation, you could do just kind of a maybe a parabola or just an exponential shape. But I love the way that you made the textured surface. That's really very nice.
Thank you. Thank you. Yes, and the parabolic curve or exponential, I'll look into that, because I do know how to incorporate kind of those simple.
Yeah, it's too simple, and then rotate it. And yeah.
Exactly. Yeah. So I will keep that in mind as well.
And I think we have time for one permissioned opinion.
Okay, I'm going to sign out, go to a different room.
Thank you, Dr. Hertzberg.
Any permission opinions for Danny?
Actually, I do have a quick one regarding the base, if you'd like to hear it, Danny.
Yeah, go for it.
I guess it's not really an opinion so much as a question for you. Would you consider sort of different variants of the base as well, or do you really like that brushed aluminum?
You know, I was just going for the brushed aluminum just to try to get that, you know, the feel of a MacBook, I guess is really what I was going for. But I'm open to hear, you know, other suggestions.
Yeah, that's cool. I actually really liked the example base in that DIY with like the rocks, kind of like a more like a garden feel to it.
Oh yeah.
That doesn't really match your aesthetic, but I just thought it was really interesting, the different sort of bases you can incorporate, or maybe you could do more of like a, maybe not, I guess it doesn't go with the curved aesthetic as much, but you could do something like prismatic with the base, like almost like a imagine like a frame based on the edges of the curves that you have right now, rather than like the solid walls.
Right.
Of course, I guess that wouldn't hide the like machinery components as well, but I guess if you combine that with the remote pump aspect, it could look good.
Yeah. Well, and I know we're running out of time, but just really quickly, it's funny you said that about the rocks, because when I first found that, I was like, oh, that's so cool, and I would love to do that. So I almost considered changing my aesthetic to something more like a, I don't know how you would call that exactly, but more of like an earthy kind of feel.
Yeah.
But then I decided, no, let me stick with the Apple aesthetic, give a little bit more of a challenge, I guess, and really go for that. So, but I agree with you. I really like that kind of rock, water, whole feel. So.
That's awesome. You did a really good job, man.
Thank you so much. And thank you all for tuning in and listening.
Great. Thanks, Danny.